Number 10, the scatter plot shows the relationship between two variables x and y. Which of the following equations is the most appropriate linear model for the data shown? You don't really have to know that much about scatter plots to get this kind of problem, right? It basically is just saying a linear model is a line that comes closest to describing the trend that we see here. So I don't know where exactly that's going to be, but I know it's something like this. I'm drawing a line that approximately goes through the points, and the answers that they give us are going to be so wildly different that there won't be a question. This is just true of the SAT in general when they have these kind of problems. It's not going to be like, oh, what if I drew the line there and the line should have been there? No, it's not going to make that big of a difference. These are always going to be so wildly different. There's no question as to which one it is. The one sort of wrinkle that comes in this one is that while at first glance it may appear that they are in y equals mx plus b or slope-intercept format, not quite. They've put the x's last and those b's are first. So just be aware of that. Our slope, our x's are here. These are our y-intercepts. And what do we have? We have two that have a y-intercept of 0.9, two that have a y-intercept of 9.4. So just by determining where the y-intercept is approximately, we can eliminate half the answers. And then we also have, we have a positive and a negative slope, and then we have a positive and a negative slope here. And if you'll notice, they all four use 0.9 and 9.4. Okay, so let's look at where my y-intercept is. I've got it going through around 9. I have two options here that have 9.4, like, okay, that could work, and two that are 0.9, which is down here. This is what I mean about the answer is, it's really obvious that I'm in the right ballpark. It's not like they're giving me a y-intercept of 9.4 and 9.2 and saying, which one do you think it is? That would require more calculation on our part, but they don't. They're saying, is it up in this area or is it down here? Like, okay, it's clearly up in this area. So my 0.9s are out. And now, I'm like, okay, well, how do I determine the slope of this? You don't have to. They both have the same slope. The only difference is one is positive and one is negative. So that's all I have to determine. This is what I mean when I say the answers are like, you don't have to do a lot of calculations. So I don't have to figure out what the exact slope would be for a line of best fit for this linear model. No, just is it positive or negative? Well, positive and negative slopes, think of them when you're, if you have a graph, if you are going left to right, if you are, like in English, if you're reading, you go left to right. And you think, someone is positive, they're upbuilding, they're like, things are going up, things are going good. Then it means it's going up. If you're going left to right, that has a positive slope. Think of somebody who's negative and they're just like, they're a downer. You're like, ugh, that person's so negative when I'm around them. I start feeling up here and I go, oh, I just get worse. I feel worse and worse the longer I'm around them. I'm sure you've met someone like that. So that is a negative slope. That's my little mental mnemonic, the way I figure it. I remember it because I read left to right and I think, okay, positive, I'm going up. Negative, I'm going down. You're like, oh, I just feel sad and negative. If you have a hard time remembering that, you can always plug in some real numbers. Like if I have, I've had a line that started at, or had the points 0, 0, and let's say it went up to 2, 2, and it's going through there. It's change in y over change in x. So change in y would be 2 minus 0. Actually, let's make this so it's more clear which ones I'm doing. Let's change that to a 3. Say 2 over 3. So the change in y would be 3 minus 0. The change in x would be 2 minus 0. The slope would be 3 halves. That's how you find the slope. You subtract the y's, you subtract the x's. And you can always do that if you have a hard time remembering which positive and negative are. But here, if we look at this line, it's clearly, no matter what its exact slope is, it is going down. This is a negative sloped line. So D is the only one that has that y-intercept in the 9s that also has a negative slope. D is my answer. Hey guys, just a quick heads up. I've got some cool stuff coming for y'all, including a free course full of SAT tips and tricks, as well as an exhaustively complete course on everything you need to know for the SAT, both math and reading. So subscribe to the channel to get notified when that goes live. I'm also going to put it in the comments and description below as soon as it does. In the meantime, if this video was helpful or useful in any way, please let YouTube know. Comment, like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.